When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way.
ATP is actually something that some of you might be familiar with, especially if you're doing bio. ATP stands for adenine triphosphate and is really important when it comes to our body because this is where we get our energy from. So you can imagine ATP to kind of be like the energy currency, our money that we have in our body to make things happen. So we use ATP to make anything move or do anything else in our body. ATP is quite important. And ATP is actually a form of ester. And the reason why we know that is because right here we have a phosphate, which was originally phosphoric acid. Phosphoric acid. And this joins together here. This was your alcohol group. This was your alcohol. And they form here to make that ester linkage, the ester bond. So overall, ATP, which we can find in our body, large amounts of it, which are quite important, is actually in ester. Another example would be triglyceride. Again, some of you bio folks might be able to remember this. Actually, you probably don't because we had never really covered this in general. You wouldn't have covered this much in class. But triglyceride refers to a fatty acid that has 3 fatty acids, which are really important when it comes to energy production. 3 fatty acids joined together. That's why it's called tri, as in 3, and glyceride because we have a glycerol molecule as well. And this is where it comes. This is why it's an ester, because the glycerol molecule, as you can see, it ends with an ol. Thereby, it itself is the alkanol. And here we have a fatty acid. These are our fatty acids. So we either have saturated or unsaturated. Again, that's not too important. But as you can see here, it has the carboxyl group, which makes it the alkanoic acid. Alkanoic acid. Now here we have this is the example of triglyceride. So triglyceride is we have one glycerol, and we combine it with 3 of these saturated or unsaturated fatty acids. So 3 of these and 1 of these together makes a triglyceride. And as you can see here, this bond here is our ester linkage. This is our ester linkage. One of the hydrogens will connect to, so here this is where they're connecting with the glycerols. These are the glycerol connecting points. And this is the fatty acid connecting point. This part of the fatty acid. And then we have, when that happens, obviously you have a water condensating out, as happens with ester linkages, but this is what we form. And triglyceride are really important. Basically, if you look at a nutritional label, and you look at, it says 0.4 grams of saturated fat, or unsaturated fat, what that means is 0.4 grams of this. They come in the triglyceride form. So that means we have 0.4 grams of saturated fat in this form. That's what our food fat comes in, what kind of form it comes in. So we can find it in our body, we can find it in food. It's quite natural as well. Another example would be fruit. So fruit itself, this would be an example of an ester found in oranges. Fruit themselves have lots of different esters, and those esters help give its flavor. So the esters give it the flavor. Each fruit has its own ester, and then it gives it its characteristic flavor. The reason why I mention this is because it says outline some examples of the occurrences, production, and uses of esters. So here, what I've given you is a couple of examples of occurrences. So natural occurrences. Where do these esters occur? Well, they occur in the form of ATP, which is in our body and is used for energy. They can occur in the form of these triglycerides, which are basically fat, which are really important when it comes to giving us energy, or also important when it comes to, for example, our cell membrane. We also have these occurrences in oranges or a different type of fruit, and the use of them in fruits is they give us good flavor. And the other part, so it says, outline some examples of the occurrences. Occurrences means where do they occur. Production actually means how are they produced. So, for example, I said that here we have a glycerol, and the glycerol oxygens, the glycerol hydroxide group here, the OH groups, they will combine with the carboxyl groups of the saturated or unsaturated, one of the two, saturated or unsaturated fatty acids. And when they combine, we have these ester bonds forming, and then we have our actual ester being formed. As that's what it means by production. So as in, what has to happen for them to actually, the ester to be there, right? So triglyceride is our ester, and production was glyceride combining with saturated or unsaturated fatty acids to form the actual triglyceride. So that's what it means by, the occurrences and the production, and the uses just refers to what they actually get used for. So I go over a couple different uses as well. Phthalate is a ester which we can find being used as a plasticizer. You might remember that word plasticizers from the production of materials module. The phthalate is actually used for something called PVC, and that was obviously polyvinyl chloride. If you remember, polyvinyl chloride, the problem with it is it's very stiff. It's very stiff. And that stiffness means it's not very flexible. So it's stiff, it's not flexible. But remember, we said that we can add a plasticizer to it, which makes it less stiff. Now, stiffness comes because we have these chains, which are all really close together. They also have really big side chains, which means they're stuck, they can't move. Flexibility happens if they can move a bit more. So what we can do is we can use this ester, which is this compound here. This is the ester phthalate. This is the ester here, this one. And this is a pretty big structure. So if you put that in, what actually happens is you can imagine it will go in between the actual chains. I'm going to try to not destroy the chains. This will be tricky. It'll go in between the chains, and thereby preventing it from being too close. Because it's a pretty decent sized structure, as you can see. So we have these esters all over the place, and we call them plasticizers, because they just change the properties of plastics. So what happens now is it changes a bit further apart, because they just can't be as close together anymore, because we have these esters in between, and that makes it more flexible. So these phthalates will make it more flexible. They're especially used with PVC, because the PVC by nature is very stiff, but we add these phthalates, they'll become more flexible. So it says, describe some of the uses of esters. We just named one. So one of the uses was as a plasticizer, especially when it comes to PVC, by making it more flexible. Another example was it's used as a biodiesel. Biodiesel means it's fuel. It's not ethanol, it's a bit different. But what we do is we have a vegetable oil. And a vegetable oil, so you can see the structure here, a vegetable oil is actually a triglyceride. So it would be one of those triglycerides. It has a glycerol backbone, and connected to it are these 3 fatty acids. That's what we mean by a vegetable oil. Right, so this vegetable oil is the same as the one as a triglyceride. So this is by itself is actually already ester, right? That's already an ester. It has a alkanol and an alkanoic acid combined together. What we do is we combine a different type of alkanol, and it's more or less just a substitution. Substitution reaction. So what happens now is our glycerol, which is here, is removed. So you can see in our product it's by itself. So it has been removed from the triglyceride, and instead we have our methanol being attached in the place of the glycerol. Sorry, and now we call it the methyl ester. And this is really a useful substance for it to be used in a biofuel. So it gives off energy, produces energy. So I just quickly outline how the production of it, right? So it says you need to know a bit about production. So here this is how it's being produced. And the use it was used in terms of energy production for cars. That's why I use it for fuel. Another example would be ink cartridges. So this is used for printing. And the reason why we use our esters is because esters are a really good solvent. Remember, a good solvent is something that dissolves stuff. If it has to dissolve stuff, like water, for example, is a good solvent. Why is water a good solvent? Because water has lots of these hydroxide groups, which make it a polar substance. And polar substances are good soluble substances. And so are these esters. So there are a couple of these areas. In this case, it's not actually a hydroxide group, but but this is still allows it to dissolve stuff. This part here, this area here. And that means it will actually dissolve the ink. So it will dissolve the ink. Dissolve the ink. And that's why we use it when it comes to ink cartridges, right? We use it as solvent property to help us dissolve the ink, and then we can print out our different types of papers. Because obviously the paper we print on, so the ink itself, was at one stage quite liquidy. And another use was the emulsifiers. They use as emulsifiers. Emulsifiers are things that keep fat and water-soluble things together. So keep fat and water-soluble things together. That's an emulsifier. So if you like usually if we've got fat somewhere, and then we've got water somewhere, the problem is they're going to separate. They're not going to mix, right? Water and fat don't like each other. They're not going to mix. They're going to stay separated, so no mixing will occur. Now these emulsifiers make sure that there's actually mixing, right? So that if we have water, that within that water we can have small fat particles more or less swimming inside. And that's really important for a lot of things, right? Because sometimes we want to have them be together to give an extra taste. Mayonnaise would be an example. And what we can do is we can use one of these esters as an emulsifying agent. So that means it helps us to make this happen. It helps us to make them dissolve together. And the reason why we can do that is because these esters have a part which helps to dissolve water. And this part would be the actual, this here. It has that O group, which is a polar group. And we said that polar groups help to dissolve stuff. So it has a polar group, but it also has lots of these hydrocarbons. It has these hydrocarbons, which are here. Lots of carbons. So it's a quite big molecule. And these carbons, hydrocarbons, will cause more dispersion forces. And through these dispersion forces, it can help dissolve fats. This makes it fat soluble. So in this case, our ester, a pretty big yeast in this case, is both water soluble and fat soluble. And that means if you have water and fat together, you can make sure that it helps it be close together. Like it makes it dissolve within each other because it's both friendly to water and both friendly to fat. So it can kind of, like it's basically the peacekeeper. It's trying to make sure that things actually mix around and don't just stay by themselves. Because they have the properties to both be friendly to fat and be friendly to water. Soluble things. So I'll go over the dot point itself again. It says outline some examples of the occurrence, production, and use of esters. Some of the occurrences were in nature were, for example, ATP. That's found in our body, and we use it for energy. And as an ester, because we have that ester linkage here between the original phosphoric acid and the alkanol group. We have it being found in fruit and other food as flavors. Right? So all different types of fruits have different flavors because of the esters found inside. We have them found as triglycerides. Triglyceride is an ester where we have a glycerol alkanol and a fatty acid alkanoic acid. When they combine, 3 fatty acids and 1 glycerol, and they combine, we form our triglyceride. So these were the natural occurrences. The productions, which is how they actually get produced, so what combines to form them. So we said, for example, here, glycerol and 3 fatty acids, when they combine, they form our triglyceride. And the uses we mentioned earlier, flavor for fruit. Triglycerides are used as energy in our body, and also used for cell membranes, for example. ATP is used for energy. Now we've got plasticizers. For example, the ester fat. I really struggle saying this word. Phthalate. I'm still probably wrong. But phthalate is a plasticizer, which means it makes things more flexible by going in between the chains, making a bit more space between the chains, which makes it more flexible, less stiff. And that's used to make PVC more flexible. We've got biodiesels, which are produced by having a vegetable oil, which was a form of triglyceride. We have that vegetable oil, which is ester. We combine that with a alkanol, and then we have a substitution reaction. We have the actual alkanol going in place of the glycerol and forming a new biodiesel. And that biodiesel is used for cars and other things for it to be able to move and do physical work. Then we also use it for ink cartridges, and the reason why is because it's a good solvent, because it has these polar groups, and these polar groups help dissolve things. And we have to dissolve ink, which is why we can use our esters to do that. And also we use it as emulsifying agents. Emulsifying agents are just things that help fat and water come together. And we said that these big esters, especially if they're bigger, not small ones, but bigger ones, they have both the fat-soluble properties, because they have lots of these dispersion forces, plus they have the polar group, which helps it dissolve water. So they're both friendly to water and fat, so kind of act like the peacekeeper to bring them all together, make sure that they mix together. And that was more or less the stop point. So it says, outline some examples of occurrences, production, and uses of esters. I hope that's useful.
Thank you for watching.